Hey, 7th grade, we're going to go ahead and get started on the last section of Chapter 9, which is Section 5. And we're going to be talking today about similar solids. Please also make sure you put the date off in the corner. Today is the 30th. Now, before we actually get started on any problems, we're going to recall what it means if you have shapes or solids that are similar. So if you have anything that is similar, it means that it's going to have the same shape, but different sizes or measurements. But all of the sides are going to be proportional. So similar shapes, let me focus this a little bit. Oh, other way. There we go. Similar shapes are always going to be the same kind of shape, but one might be bigger, one might be smaller, and they're always going to have proportional sizes. So we're going to go ahead and get started. I'm going to put a number 1, and we're going to be finding the unknown length. All right. There were some cutouts that went along with this section. If you did not print them out, go ahead, pause the video, and do that now before you get started. So I'm going to put an A, and this is the first cutout that I'm going to go ahead and glue in. So I'm going to pause and be right back. All right, so I have mine glued in. I'm going to go ahead and get started. So whenever you're comparing similar solids, you always want to match up the corresponding sides. What do I mean by corresponding sides? Well, if you think about it, if I'm looking at this smaller square pyramid, which length in the bigger one is it going to match up with? Well, it's going to match up with the 12th because it's in the same spot. It's measuring the same length of the square pyramid, and I can also see that it is marked by a right angle. So I know that 5 centimeters matches up with 12 centimeters. So I'm going to set that up like a ratio, 5/12. Now, the unknown side I want to find, I'm going to make it a little more clear, is this X down here. So you'll notice in the first ratio that I set up, I started with the small square pyramid and put that over the large one. I'm going to do the same thing over here. Small over large. I know that this 6 centimeters matches up, corresponds with the X in the large square pyramid. Now you could have written it the other way. I could have done 12/5 equals X over 6. As long as you're consistent, it doesn't matter if you start with the big one or if you start with the small one. It just has to be the same for both of your ratios. So now I am ready to figure out what X is, and I'm going to solve that by doing cross multiplication. So that would give me 5x equals 72. On both sides, I'm going to divide by 5. And from here, if you have a calculator, go ahead and grab it. So 72 divided by 5. That gives me x equals 14.4 centimeters. So that is how you find the unknown length in similar solids. Let's go ahead and try another one. I'm going to go to the top of a new page, and this is the next cutout that you should have. So I'm going to put B, I'm going to pause, and I'm going to glue that in. Alright, so mine is glued in. I'm going to go ahead and get started. So it says 2 cylinders are similar. The small cylinder has a diameter of 4 meters and a height of h. The large cylinder has a diameter of 5 meters and a height of 11. What is the value of h? So what I'm going to do, I'm actually going to go ahead and draw this just so I can get a visual. So I'm going to draw a small cylinder and a larger one. These don't have to be exact, just as long as you can get a visual of what it's looking like. That's all you need. Okay, so here we go. Let me go ahead and label these. So small cylinder has a diameter of 4 meters, so that means it goes from one side through the middle and to the other. So this is 4 meters. And a height of h, so going from the bottom of the cylinder to the top. The large one has a diameter of 5. This is 5 meters. And a height of 11. Alright, now we're trying to find the value of h. So we're going to go ahead and set this up. I'm actually going to show you 2 ways that you can set it up, because you could do it with corresponding sides, or you could do it within the solid itself. So I'm going to show you 2 ways that you could set it up. Alright, so I'm going to start with, I'm going to do small to large. So I'm going to start with the diameters. So this is going to be the small over the large equals small height, which I don't know yet, over large height. Okay, so from there, I'm going to cross multiply, and I get 5h equals 44. I'm going to go ahead and divide by 5 on both sides. From there, I grab my calculator, and I do 44 divided by 5. And I get that h is 8.8 meters. So that is the height of my small cylinder. Now, there's another way you could have set this up and still gotten the same answer. And I'm going to show you how that would work. So let's say I did it within the shape itself, because the proportion that I make within the solid should be the same proportion as in the other solid. And here's what I mean by that. I could have done diameter over height, and still gotten the same answer. So I could have done 4 over h, actually let me put 4, there we go. 4 over h equals 5 over 11. Okay, you'll notice that I have diameter over height. And when I go to cross multiply, I end up multiplying the same values in this one that I did over here. I get 5h equals 44. I divide by 5 on both sides, and I get that h is 8.8 meters. Okay, so you can set it up as corresponding sides or within the solid itself. And you should, if you set it up correctly, you should still get the same exact answer. Alright, so that is how you find unknown lengths in similar solids. We're going to try something else now. Not only can we compare the side lengths within solids, but we can also compare the surface area and the volume. And we're going to do this real quick. Let's say we had 2 solids. I'm just going to draw them real quick. Alright, let's say we've got this solid here. We'll make it be a cube. Okay. Alright, solid 1 and solid number 2. I'm just drawing these so that we can have some kind of visual when we write this next part down. Okay. Alright, so these 2 figures are similar to each other. And let's say that my small one has a side length of A, and my large one has a side length of B. I can set this up a few different ways. If I'm comparing the sides, the ratio will always be A to B. If I'm comparing surface area, the ratio will be kind of similar, but it will be A squared over B squared. Because remember, when we do surface area, it's always the unit squared. And if I am comparing volume, the ratio will always be A cubed over B cubed. Because remember, whenever we do volume, our unit is always cubed. So we can use these comparisons and find unknown surface areas and volumes in other solids. And this is true for any similar solids. It doesn't have to be a cube. It can be a cylinder, it can be a square pyramid, it can be a pentagonal prism, it can be any kind of solid, and as long as they are similar, these three things will be true. Alright, so I'm going to go ahead and flip my page, and I'm at the top of a new page. I'm going to put a number 2, and we're going to put in our next cutout, which should look something like this guy. So go ahead, pause, and glue him in. Alrighty, so I have mine glued in. I'm going to go ahead and get started. For the sake of this problem, we're just going to pretend that these two things are cylinders, because it might just make it a little bit easier for us. Alright, so it says the surface area of the cylindrical pitcher, so talking about the bigger one, is about 90 inches squared. Its volume is about 157 inches cubed. The pitcher and the creamer, so the little guy here, are similar. Find the surface area and volume of the creamer. Alright, so the first thing I'm going to do is find the ratio, the relationship between the pitcher and the creamer. So I'm going to go ahead and do that. So I'm going to set it up as the measurement of the pitcher over the measurement of the creamer. So let's compare their diameters first. So the pitcher is 6 inches in its diameter, and the creamer is 3 inches, which, when I simplify it, is 2 over 1. So I'm going to just leave it like that. I'm not going to write it as 2. I'm going to leave it as a fraction because I know that I'm going to have to compare not only the surface areas but also the volumes. Okay, so this is the ratio of the side lengths, or I should say of the diameters, not side lengths, diameters. There we go. Perfect. All right. So let's compare surface areas. I'm just going to abbreviate it as SA. Well, we know that the ratio of the diameters was 2 to 1. But when I write the surface area, remember, it's A squared over B squared. So if I'm looking at the relationship between the surface areas, it's going to be this ratio that I just found, but I'm going to square both the top and the bottom. So it would be 2 squared over 1 squared. So that means when I'm comparing the surface areas, it's going to be 4 over 1. So let's go ahead and figure out what the surface area of the smaller, the creamer, is going to be. So we have 4 over 1. So this tells me that the pitcher is going to be 4 times larger, the surface area, than the creamer. So I'm going to set that equal. We know that the surface area of the pitcher, the larger one, is 90. But we don't know the surface area of the creamer. I'm just going to write that as C. So I'm going to go ahead and do the same thing that I did before to solve. I'm going to cross multiply. And I get that 90 equals 4C. From there, I'm going to go ahead and divide by 4 on both sides. And I'm going to grab my handy dandy calculator and do 90 divided by 4. And I get that C is, and I'm going to put a label on this, this is inches, so inches squared is the surface area of the small, of the creamer, they're calling it. Okay, so once you have your ratio, so this is the ratio for the diameters, this is the ratio for the surface areas, and what I do is I set that equal to what I know and what I don't know. Okay, you just want to make sure you put it in the right order. So this was the larger over the smaller, so I have to do larger over smaller. And we're going to do the same thing for volume. Okay, so for the the diameters, we knew that it was 2 over 1. But remember, when I'm doing volume, it becomes cubed. So I'm going to take that ratio for the side lengths, which was 2 over 1, and I'm going to cube both the top and the bottom. So this is like 2 cubed over 1 cubed. So when I'm comparing the volumes, instead of a 2-to-1 ratio, it's going to be an 8-to-1 ratio. You can see how much bigger it gets going from the ratio of the diameters to the ratio of the volumes. All right, so let's go ahead and figure out what the volume of the creamer is. So we're using 8-to-1, 8 over 1. We know the area of the larger, which was 157 inches cubed. We do not know the volume of the smaller. And again, I'm just going to use C to represent the volume of the creamer. So we're going to go ahead, cross multiply. 157 is going to be equal to 8C. And again, I'm going to grab my handy dandy calculator because I know I have to divide by 8 on both sides. So 157 divided by 8. And I'm actually going to just write out the whole thing. 19 and 625 thousandths inches cubed is the volume of the smaller. All right, and that is how you find volume and surface area of similar solids. We're going to go ahead and do one more, and I'm going to go to the top. I'm actually going to have you pause and try it on your own first, and then unpause and see if your answers match up with mine. So go ahead, pause. I'm actually going to pause and glue in, and then I will do the problem. All right, so it says a box has a surface area of about 54 inches squared and a volume of about 27 inches cubed. The edge lengths of the box are about 1/3 of the edge of the length of the larger box. Find the surface area and volume of the larger box. I actually don't even need to know what the lengths are because they already give me the ratio. So 1/3, this is going to be the smaller over the larger. All right, so this is the ratio for the sides, which means that for surface area, it's going to be a squared over b squared, so 1 squared over 3 squared. So for surface area, the ratio that I'm going to use is 1 over 9. So let's go ahead and do surface area first. Surface area. All right. So smaller over larger. We know, find the surface area. Oh, okay, so we are given the smaller. We are trying to find the larger. So we are given the smaller, which is 54 inches squared. We're trying to find the larger one, which I'll just call X. So we're going to cross multiply on both of those. So 9 times 54. That gives me 1x equals 486, and that would be inches squared. I don't actually have to divide by 1 because even if I do that, I'm going to end up getting the same thing. So this is the surface area of my larger box. Let's go ahead and figure out volume. And I'm actually going to write what the ratio is up here because, so this was surface area. Volume is going to be whatever my ratio was, but I'm going to cube each of the measurements, the top and the bottom. So the ratio for my volume is going to be 1 to 27, smaller to larger. So we're going to use that ratio. The smaller they gave us, which they said was 27 inches cubed, we do not know the larger. That's what we're trying to figure out. So again, we're going to cross multiply. We do 27 times 27, which gives us 1x equals 729 inches cubed for the volume of the larger. And again, I don't have to divide by 1 because if I do that, I'm just going to end up getting the same thing. So we're done there. So that is how you find surface area and volume of similar figures. What you're going to do now is pause, and I'm going to try to find a topic on IXL where you guys can practice this skill.